Hi guys, my name is Leo, first year PhD at the University of Maryland. I'm gonna present my work, HumanEgo, zero-shot robot learning from millions of HumanEgo-centric videos. The objectives of this paper is straightforward. If we only have 30 minutes of HumanEgo-centric data to train robot policy, what representation and architecture should we use will maximize learning efficiency? HumanEgo is designed to answer this question. Okay, let's get started. For human to robot transfer, all you need is someone wearing meta-red glasses, collecting minutes of data with their own hands. During pre-processing, first we use area slam to transform everything into a steady word frame. Second, we do hand-to-gripper mapping to translate human hand motion into gripper actions. For visual part, we do arm inpainting to remove the arm, then rename the hand and object back as colored key points. It all runs on off-the-shelf foundation models, give us an embodiment-agnostic observation. Furthermore, here's a fun little experiment. In this task, I only glance at the scene once, and then look away and finish the whole thing with no vision at all. Which tells us vision isn't that necessary. What really needs is spatial observation. So based on that, we introduce interaction-centric tokens, or ICT. We treat every hand and object as an entity, and each token encodes its type, its pose, each hand's pose relative to it, which captures the manipulation state. This turns the problem from inferring 3D dynamics from pixels into learning actions from explicit spatial relationship. It's unified, self-sufficient, variable length, and embodiment environment representation. For architecture, we use flow matching, and we also add 3 auxiliary objectives sharing the same encoder: object motion, 2D trace, and latent consistency, trying to squeeze more signals from the same demonstration and force the encoder to learn the causal structure of the manipulation. So this is the final architecture. So now let's take a comprehensive evaluation of our method. We evaluate on 4 real-world tasks against 6 baselines, all trained on 30 minutes of data per task. Here is the result. HumanEgo achieved 92.5 success rates, the highest on every single task. And even with just 15 minutes of data, it still hits 75, outperforming any methods, including ACT trained on robot type data. Here are some real-world video clips. We also ran a zero-shot generalization study, like cross-embodiment, environment, and cross-setup. In every case, HumanEgo generalized zero-shot with almost no drop, staying above 85%. Here are some examples of robustness testing. To wrap up, here is the summary videos.